Hello everyone. So in our previous video, we discussed about that how we can remove a loop from a singly linked list. We saw an animation of the algorithm. So in this video, we'll write the code for that and we'll test its working in the main method. So here in our singly linked list class, which has this instance variable head of type list node. So here inside this class, I have demonstrated so many algorithms related to singly linked list. So here you can see the last algorithm we discussed was how to find the starting node of the loop, where we first created the loop, then we simply checked that whether there is any loop or not, and once we found that there is a loop, we wrote the algorithm for finding the starting node of the loop and we printed its data on the console. So here you can see that we used a simple example which we also saw in our previous slide, that we have created 6 nodes, first, second, third, fourth, fifth, sixth, where all the nodes are connected to each other and the last node is connected to node third. So node 6 was connected to node third, which created the loop in the singly linked list. So head pointed to first node, first pointed to second, second pointed to third, third pointed to fourth, fourth pointed to fifth, fifth pointed to sixth, and sixth pointed back to third. So there was a loop and the starting point of that loop was node third. So if I run the code now, which we already discussed in our previous videos, so here you can see the starting point of that loop was at node 3, where we printed its data on the console. So in this video, we'll look into algorithm where we'll simply break the loop, which means that from node 6 to node 3rd, we'll break this link and then 6th node will point to null. So let's code the algorithm. So friends, here you can see that this algorithm of removing the loop from the singly linked list has two parts. One is to detect the loop and part 2 is to actually remove the loop. So here in our previous videos, we already discussed that how we can detect a loop in a singly linked list using Floyd cycle detection algorithm, and we also saw the proof for that algorithm. So here, when fast pointer will meet the slow pointer, then instead of going and finding the starting node, what we'll do is we will remove the loop. So the first part of the algorithm is pretty much the same. I'll paste the code here, and instead of returning the list node, as we are not returning anything, we will make it void. We'll name the method as remove loop, and rest of the part remains same till the cycle is detected where fast pointer is equal to slow pointer, which we already discussed in our previous videos. We'll remove this return null, and here instead of going and finding the starting node of the loop, what we'll do, we'll simply create a method as remove loop and we pass in the slow pointer, and once we remove the loop, we'll simply return from this while loop, or we can break the while loop. So here I'll be creating one private method as remove loop, which will take in a list node slow pointer, which is we are calling this method from here, and inside this method we'll actually write the code to remove the loop. We also discussed that how we can find the starting node of the loop. So the idea of finding the starting node of the loop and to remove the loop is pretty much the same with only small changes. So I will copy this part. So here we have the slow pointer, which is nothing but the meeting point of fast pointer and slow pointer, and we pass slow pointer into this method. So we have this slow pointer here, and inside this remove loop method we are creating this temporary variable which will start from head. So friends, when we discussed that how we can find the starting node, what we did was we made slow pointer move one step and we made temporary pointer move one step inside this while loop, and when they met, so temp became equal to slow pointer. So at whichever node this both pointer met, that node was our starting node of the loop, and we proved this algorithm in our previous videos. So similar concept is applied here. Here the only change we do is we simply check whether temp.next should not be equal to slow pointers next. So why we have provided this condition is, here this condition will make us reach to the starting point of the loop, but we don't want to go till the starting point of the loop. We have to just go a node before that, because as it is a singly linked list, in order to break this chain, we have to go a node before the starting point of the loop, and once we reach there, we can simply break the chain by assigning something like slow pointer dot next equals null. So friend, this condition is important. If we remove this dot next from both the sides, then this while loop will make slow pointer and temporary pointer to reach to the starting point of the loop, but we don't want to go to the starting point of the loop. We have to go just before that. So wherever these both the pointers are, we are simply comparing its next value. So if both the pointers next value becomes equal, then we know that slow pointer is just before the starting point of the loop. And once this condition comes out to be false, we know that slow pointer is just before the starting point of the loop. So friends, here you can see that why this condition is important. If we don't provide dot next value in both these pointers, then this while loop will make us reach to the starting point of the loop, and we don't want to reach to the starting point of the loop, because if we reach to the starting point of the loop, then we won't able to break the cycle. So what we do is we simply try to reach a node before the starting point of the loop. So here, instead of comparing temp with slow pointer, we are simply comparing both the pointers next, so that when slow pointer will be a node before the starting point of the loop, its next will point to the starting point of the loop, and temp next will also point to that node. So this condition will come out to be false, which means our slow pointer will be a node before the starting point of the loop, and then at the last step we'll simply assign null value to slow pointers next. So this will break the cycle of the loop which is inside the singly linked list. So here what we do is, in the main method, we simply call the remove loop method. So this will take this singly linked list which contains the loop, and then we'll simply call display method which will print the singly linked list. And if the singly linked list will contain a loop, then here you can see that display method will keep on running, because it won't break, because there won't be any null value, and this will keep on going. But here, as we know that we are removing this loop here, if I run the code now, so here you can see that from third node it pointed to fourth, then fifth, then sixth, and sixth again pointed to node 3, which we saw here. 6 next is pointing to third. But when we called remove loop method, here the loop was removed, and when we printed the singly linked list on the console, this step made the 6th next to null instead of pointing to 3. So it simply removed the cycle from the singly linked list, and it printed it on the console, where the last node was now 6 pointing to null. So friend, this was all about that how we can remove a loop from a singly linked list. I hope you have find this information useful, and in case if you find this information useful, then please like this video, and if you are new to my channel, then please subscribe to my channel so that you never miss any update. Thanks, have a nice day.